Dear students, in this video we are going to learn break-even analysis. Break-even analysis has various applications. In this particular application we are going to use break-even analysis to compare various manufacturing options an organization has and to choose among them a suitable or least cost option. So for this some theoretical aspects first. So the choice of a specific equipment or manufacturing option to use in a process often can be based on the analysis of cost trade-offs. There is often a trade-off between more and less specialized equipment for manufacturing option. More specialized equipment usually has high initial investment compared to the low in specialized equipment. On the other hand, the more specialized equipment has better productivity in terms of higher operational speeds, higher accuracy, and hence lower wastages and superior quality final products. Hence, often the more specialized equipment generally has a lower per unit running cost. So let us understand this with understand the calculations involved using an example from Jacobs on page 154. So the example goes like this. Suppose a manufacturer has identified the following options for obtaining a machined part. It can buy the part at $200 per unit including materials. It can make the part on a numerically controlled semi-automatic lathe at $75 per unit including materials. And the third option is, or it can make the part on a machining center at $15 per unit including materials. There is negligible fixed cost if the item is purchased, that is the first option. In the second option, a semi-automatic lathe costs $80,000, and the third option, a machining center costs $200,000. So these are the initial investments. So the total cost for each option can be put into equations like this. If you are buying it out, purchase cost will be $200 into demand. If you are producing using a lathe machine, semi-automatic lathe machine, then the cost can be $80,000 plus 75 into demand. And using a machining center, costs will be 200,000 plus 15 into demand. And the part is sales at $300 per unit. So we need to perform the break-even analysis and give suggestions to the management. So how we will go about this? Let us, it is a graphical method, so we have to plot 4 lines on the graph, taking demand on x-axis and cost or revenue on y-axis. So first revenue line, revenue equal to 300 into demand, because 300 per unit is the revenue. And the other purchase cost options, cost purchase is 200 into demand. Then cost semi-automatic lathe machine is 80,000 plus 75 into demand. And cost machining center is 200,000 plus 15 into demand. So we need to put this on one single graph, and we don't have to use a graph paper as such. We can have a rough or a approximate graph made using pencil and paper. So for drawing each of these line will require 2 points. So we are going to use demand 0, what is the revenue or the cost, and with demand 1000, what is the revenue or cost. So for each line we have created 2 points here. For the revenue line it will be 0, 0 and 1000 and 3 300,000. For cost purchase, it will be 00, 1000 and 2000, like this. For semi-automatic, it will be 0, 80,000, first point, 1000, 1,55,000, second point, and for cost machining center, it will be 0, 200,000 and 1,000, 215,000. So these are the 2 points. First point, second point will give you revenue. First point, second point will give you. So you need to just plot them and connect them. So you see this is our revenue line. Then this is our buying or purchase material directly line. Then this line, which is starting at 80,000 and the other point is 1,000 and 155,000, is your semi-automatic lathe line. So simply the 2 points you need to connect with a proper scale and a pencil. And then the last line is machining center line. The first point is 0 to 200,000. Here it is in thousands. So 0 200,000 is the first point, and 1,000 and 215,000 is the second point. Now if you closely observe this graph, okay, you can see that the lines are intersecting with each other and forming a area which is on the bottom of all the lines. This is the area which is having the lowest cost, right? And the edge of this lowest cost region will be from 0 to B, or origin B, then B to A, and A onwards. So this green line is our edges for the lowest cost area. So our lowest cost option will be lying on this edges only. So we need to now find out the coordinates. We know that this is 0, 0 coordinate. For B option we need to find a coordinate. For A point also we need to find a coordinate. Now how to find a coordinate? We need to solve. For B we need to solve equations of this line, that is buying line, and this line, which is semi-automatic line, simultaneously. To solve A, we need to simultaneously solve the equations for machining center total cost and semi-automatic total cost. So that is how we will be able to get the points B and A. So that is how, what is shown here now. To arrive at point A, we will solve semi-automatic lathe equation. Cost of total cost is this, 80,000 plus 75 into demand, and machining center 200,000 plus 15 into demand. So at this point A, both the costs are equal, getting equal. So we need to equate these two equations. So the right hand side of this and right hand side of this, if you equate and then solve for the demand, you will get 2000 units. So that means what? This point A is having a demand of 2000, right? Similarly, point B, you need to solve the other two, that is purchase 200,000, this one, this line and this line together, and we get demand here as 640 units. That means your B point is at 640 units, right? So if you can clearly see this, what is the choice here? So up to 640 units, this line will give you the lowest cost and hence the highest revenue. The vertical distance between the red line, revenue line, at any point, the vertical distance between these two gives you the profit. So up to 640, if the demand is below 640, your choice is directly buy at $200 per unit and you can sell it at $300 per unit. From B to A, the line which is semi-automatic lathe gives you the lowest cost. So when the demand increases above 640 but it is still within 2000, your option is semi-automatic lathe machine. And If the demand increases beyond 2000, then the best option would be the machining center, because it's very low from here, and you will see that the profits will be very high. So that is how we conclude. The conclusion is, if the demand is below 640, go for purchasing option. If the demand is between 640 and 2000, go for semi-automatic lathe as the best option, and beyond 2000 units, go for machining center, as it is the most economical choice. Now, in case you need to find out the profit, the profit is nothing but revenue minus the cost. So you need to see where they have asked, at what demand they have asked, and then what is the economic choice, the economic option you are choosing, and accordingly you will calculate the profit. This is how you perform break-even analysis in case of comparing various manufacturing options. Thank you.